Hello, this is Mrs. Pellegrino, and I'm going to work out a Punnett Square practice problem with you guys so that you can finish the rest of this practice by yourself and hopefully have no issues. So the one that I'm going to do with you guys is number 1, and this is a monohybrid cross. Okay, in the next video, I will do a dihybrid cross, so be sure to look out for that. Number 1 says deafness in Cocker Spaniels is inherited. The allele for deafness is recessive to the allele for normal hearing. 2 Cocker Spaniels with normal hearing are mated together. They produce a litter of 8 pups, 2 of which are found to be deaf. Now, when we're looking at a Punnett Square practice problem, or whether it be on a quiz or a test, these questions can be a little intimidating, and I like to break them down to make it a little easier for myself. So the first thing that I always do is I write the allele, or I write the alleles, what letter they are. And in this question, we are not given letters for our genotypes. Like number 2, for example, having dimples is capital D dominant, and not having dimples is recessive, lowercase d. It doesn't tell us, capital D, lowercase d. So we're going to have to pick our own letter. And I'm going to use the letter F. And capital letter F is going to represent my dominant allele, which in this case is normal hearing. And lowercase f is going to represent our recessive allele, which is deafness. Okay, then part A asks you to give the genotypes of the parents. And it doesn't just explicitly tell you, but it does give you a clue. It says 2 Cocker Spaniels with normal hearing are mated together. Now, if you have a Cocker Spaniel with normal hearing, you have to either be homozygous dominant or heterozygous. Both of these would display the dominant trait, which is normal hearing. Well, how do I know which one to use? Well, if you continue reading, it says that they produce a litter of 8 pups, and 2 of which are found to be deaf. Well, in order for the 2 pups to be deaf, the parents have to carry the recessive allele. So they have to be heterozygous. So I'm going to write that out. Then the next thing that we need to do is show the possible genotypes, phenotypes, and probabilities for the offspring. So I'm going to start with my Punnett square. I'm going to write the genotype of one parent on the top and the genotype of the other parent on the left-hand side. And it does not matter which parent you choose to be on the top or the left-hand side, even if they were not the same. Okay, and when I cross them in this first quadrant, this first probability would be homozygous dominant. This next one would be heterozygous. This one would also be heterozygous. The last one would be homozygous recessive. Now we need to find the genotype and phenotype probabilities. Remember that genotypes are represented by the letters. So there are 3 possible genotypes that we could have here. We could have homozygous dominant, heterozygous, or homozygous recessive. Now, in our Punnett square, how many individuals, or how many of the squares, would be homozygous dominant? This one. 1 out of 4. Now, it does not tell us whether it wants a ratio or a percentage. I'm going to stick with a percentage. So 1 out of 4 would be 25%. How many would be heterozygous? Well, this one and this one. So that would be 2 out of the 4 would be 50%. How many would be homozygous recessive? 1 out of the 4, 25%. The next thing we need to find are the phenotype probabilities. There's only 2 phenotypes. Phenotypes are the physical trait. Normal hearing or deafness. How many out of the 4 in the Punnett square will have the normal phenotype? Well, the homozygous dominant will definitely be normal and, well, have normal hearing. The heterozygous ones will also have normal hearing. So 3 out of the 4 will have normal hearing, or 75%. How many will display the deafness phenotype? 1. So 25%. And if you have done this correctly, these should total 100%. So that's just a easy way to check yourself. If they don't, then you have done something incorrect. Part B, how many of the puppies will be unable to produce deaf offspring? This one's a tricky question. If you recall, how many puppies were made from these 2 parents? It says 8. So how many out of the 8 will be unable to produce deaf offspring? Okay, so I'm going to switch it up and say, well, how would you be able to produce deaf offspring? Well, to produce deaf offspring, you would either have to be a carrier or present the deaf phenotype. So to be a carrier, you would have to be heterozygous. You carry this recessive allele. And then to be deaf, you carry 2 recessive alleles. So heterozygous individuals and homozygous recessive individuals have the ability to produce deaf offspring because they carry the recessive allele. But our question asks, what about the ones that are unable to produce deaf offspring? Well, if you are homozygous dominant, you do not have the recessive allele. If you do not have the recessive allele, you have no recessive trait to pass on. Well, out of these 4 possibilities, only one of them is homozygous dominant. 1 out of the 4. We said that here. But we have 8 puppies total, so we need to think about how many would 8 of these have? It would be 2. So 2 out of the 8 puppies would be unable to produce deaf offspring. That concludes our monohybrid practice problem. Feel free to work out the rest of the monohybrid crosses on this Punnett Square practice, and then I will post the dihybrid cross momentarily. All right, thank you so much, and have fun doing Punnett Squares.